Hi, this lesson we will look at Statistic 1 Probability Partial Questions. I will refer to the syllabus so that we will know what syllabus wants candidate be able to do. And then we are taking a partial question as a discussion here. Now, let's see what candidates should be able to calculate and use conditional probabilities in simple cases. Right, so examples, we have to be able to use the tree diagrams, and then the use of this formula will be required. All right, so this is the conditional probability formula, which is not given during exam. It's not given. So we have to remember, and then when do we use this conditional probability? When we read the exam questions and it emphasizes the word given. So when we see the keyword given, or sometimes it might use the word if, then we know we are going to use these conditional probabilities. Now, if you are going to look for details discussions of the chapter probabilities, you can refer to my previous video. So in this video, we will focus on the particular questions that using tree diagram to find conditional probability. All right. And if you like this video, do subscribe to the channel and like the video. Okay, have a lot of questions here. Tom and Ben play a game repeatedly. The probability that Tom wins any game is 0.3. Each game is won by either Tom or Ben. Tom and Ben stop playing when one of them, to be called the champion, has won 2 games. Okay, 2 games. Now, to find part 1, find the probability that it's not Tom, Ben becomes the champion after playing exactly 2 games. So in order to find the probability, we are trying to use the tree diagram. So Tom and Ben, and according to the questions, Tom wins the game is 0.3. 0.3. And since the question says that the game is won by either Tom or Ben, means the probability that Ben wins the game is going to be 0.7. Right? Total, the probability equals to 1. And then they have to get 2 games to be called the champion. So we move on to the second game. Now, constructing the tree diagram, if Tom wins, probability 0.3. If Ben wins, probability 0.7. All right. So we are going to list down the outcomes that after 2 games, who wins the to be called the champion, right? Who won 2 games. Now, answering part 1, find the probability that Ben becomes the champion after playing exactly 2 games. It means that we're looking at the probability. First game is won by Ben, and second game is won by Ben. So as we can look at the tree diagram, we know this is the outcome that we want. So probability, Ben won the first game, 0.7, and the second game. So it's 0.7 times 0.7, and the probability found to be 0.49. Okay, so now we move on to part 2. Find the probability that Ben becomes the champion. So the slight difference compared to the first question is the Ben has to become the champion after exactly 2 games. Simply means Ben must win 2 consecutive games, right, in order to become the champion in exactly 2 games. But part 2 is asking for Ben to become the champion. And for that to happen, they might have to play up to 3 games, right? Why do I say so? Now, let's see. If, according to the first outcome, Tom wins the first and second games, then Tom's become the champion, right? They do not have to play anymore. So there's no more after 2 games. But what happens if Tom wins the first game, then followed by Ben wins the second game? So they have to play the third game, and the probability Tom wins is 0.3 still, and Ben wins is 0.7. All right. Or maybe Ben wins the first game, and then followed by Tom's win the second game. This is where they have to play the third game, and with the same probability. So this is the probability tree diagrams that there will become, one of them will become the champion. So now we try to find the probability that Ben becomes the champion as long as Ben wins 2 games. So let's see. For the first outcome here, Tom wins 2 games. So obviously that's not what we want. So the outcomes is here. They play 3 games altogether. First game won by Tom, followed by the next 2 games won by Ben. So this is where Ben becomes the champion. All right. Or these outcomes. Ben wins the first and the third games. So Ben becomes the champions. Or even better, Tom wins 2 games consecutively and then becomes the champion. So this is the 3 possible outcomes that Ben become the champion. Ben wins, right? So look at the probability calculation. From the first outcome, we know Tom wins 0.3 and followed by Ben wins and Ben wins. Or, so another possible outcome, then we sum up with, first one is won by Ben, 0.7, followed by Tom wins, 0.3. And finally, third game won by Ben, 0.7. All right, or Ben wins 2 games, 0.7 times 0.7. Okay, then we can do the calculations and we will get the probability to be 0.784. Okay, so that is why the probability calculations for Ben wins and becomes the champion. So now we move on to the third. So you can see that the part 3, given. So in a probability questions, where the question use the word given, is asking for conditional probability here. So given that Tom becomes the champion, find the probability that he won the second game. So this is what the question wants. According to the formula, whatever is given means it has already occurred, that you put it at the back, given that Tom becomes the champion. So in this case, Tom wins. And then what we want to find is the probability that Tom won the second game. So second game. So what do we want to find? Follow the formula is the first event intersect with second event. And then divided by the probability of the second event, which is something has already occurred. Right? So when you are told, given that Tom becomes the champion, now the denominator will be narrowed down to the probability that Tom wins, right? Tom becomes the champion. So on top of it, what is the probability that Tom wins with the second game? All right, So this is what we are trying to find. So in order to find out the probability, we have to use the tree diagram that we have constructed in part 1, and then try to find the probability for both the numerator and the denominator. Now, let's see the numerator. We are looking at the intersections of these two events. The first event is saying that Tom wins the second game. And second event is saying that Tom wins. That means Tom becomes the champion. So Tom must have 2 games, right? Tom must have 1, 2 games. So we look for the outcomes that Tom wins. So where are the outcomes that Tom wins? Maybe I'm using different color. Okay, the gray here, Tom wins. So if Tom, this color is not nice. Choose a different color, green color. Okay, so if Tom wins 2 games consecutively, then Tom becomes the champion, right? Or else is this. Tom wins the first and the third games. Tom becomes the champion. Or this. Tom wins on the second and the third games. Tom is the champion, right? So these are the 3 outcomes that Tom wins and Tom becomes the champion. But then if we are trying to understand the events on the numerator, so not only that Tom must win, at the same time intersecting, right? Tom must win with the second game. So we can see that this one, second game, Tom wins. So this is the outcome that satisfies the numerator of these 2 events, the intersection of the 2 events. But then the second one, it does not, because second game is not won by Tom. So this is not. Okay, then the third outcomes, Tom wins because have consecutive 2 games won by Tom. At the same time, second game is won by Tom. This is also what we want, an outcome that satisfies the numerator, the intersection of these 2 events. Okay, so then we have found the probability for numerator. So Tom wins the first game and Tom wins the second game. So Tom becomes a champion. At the same time, Tom wins the second game. Okay, or first game is won by Ben, 0.7, and second game is won by Tom. That is what the first event. At the same time, the third game is won by Tom, and then Tom becomes the champion. So these are the outcomes that give us the probability for the intersection that we have found. Okay, now we move on to look at the probability for denominator. So for denominator, we are trying to find the probability that Tom wins, right? And basically, they are the outcomes of this that I have already considered here. Now I label them in black color. So this is the probability that Tom wins. As long as out of 3 games, Tom wins 2 games. So we can try to consider these probability calculations, or else refer to the part 2. We have already found the probability that Ben wins, right? And according to the questions, the game is either won by Tom or Ben. So in this case, denominator, to find the probability that Tom wins, we can just take the probability of 1 minus the probability that Ben wins, which is 1 minus 0.784. So by doing so, we are getting the probability that Tom wins. Okay, so either you find the probability for denominator to find the outcome from here, here, or here, or you can just straight away take 1 minus probability of Ben wins, then you will get. So with these calculations, then we will be able to get to the probability for numerator is 0.153, right? And denominator is 0.216. And hence, this conditional probability is 0.708 round off to 3 SF. All right, so this is an example, a partial question taken, focus mainly on the conditional probability where we are using the tree diagram. All right, that's all for this lesson, and see you in the next one. Do subscribe to the channel and like this video. Bye-bye.
That's all for today's video. If you're interested in more genuine sharing by other geniuses, please subscribe to our channel and don't forget to turn on the notification bell, ding dong. Also, if you're struggling with 1 or 2 past year questions and the mark scheme just doesn't seem to help, Genie has got you covered. Feel free to let us know what question it is by filling in the Google form linked in the description below. GenieUs Hub will get genius teachers to fulfill your request for the solution. Genie will see you next time. Bye-bye.